This will be a short video on scientific notation. You're likely quite familiar with it, but it's just a refresher in case you need it. So watch as much as you need. There will be a worksheet, or if you find yourself struggling through worksheets, you can always come back and reference this. So the first thing is scientific notation. It's used for numbers that are really, really big or really, really small. Instead of having to write out lots of zeros, we can write it in a more compact form. Just saves us lots of writing because we do work with really, really big numbers and really, really small numbers in this class because atoms are tiny. So if we talk about their mass, we're going to talk about really small numbers in terms of grams. If we start counting them, we start talking about really, really big numbers. So you can see that we have here, scientific notation is always a number times 10 to a power. Now this number here, it has to be between 1 and 10, or 1 and 9.9999. And then the n value is an integer. It can be positive or negative. So you can see examples here of integers. So let's move on. Now, this isn't going to make a whole lot of sense at this point, but save this for later. All digits in scientific notation are significant. So when you look at a number in scientific notation, all the numbers here, you count them, they're all significant. Again, that'll make more sense later. Now, a little trick here, you can write this down. If a number that you want to write in scientific notation is big or greater than 1, the n value will be positive. If it's a really small number or less than 1, it's negative. So the best way to show this is an example. So I know that because this is a positive number, that the value of this whole thing is going to be big, or at least greater than 1. Because this is negative, I know that this number is less than 1. Less than 1. This number is greater than 1. So that's just a little hint. So positive exponent, big number, negative exponent, it's going to be a decimal. So let's do some examples together. And I know you've probably learned the rules. If you move it to the left, it's a negative or a positive exponent. I don't even remember the rules. I try not to follow rules like that because they're easy to forget. But if you understand kind of what's happening, you don't have to remember them. You just know how to do it. So here's kind of how I like to teach it. I always say, okay, to make this in scientific notation, I need to make a number between 1 and 10. So that number is, I usually take the first non-zero number and put the decimal after it. So I'm going to write 6.3. So I want the decimal to be here. It's currently here. So I count 1, 2, 3, 4. It takes 4 jumps to get the decimal from where it was to where I want it to be when I write it in scientific notation. So I write times 10. The 4 comes from the fact that I jumped 4 times. Now instead of remembering, okay, I went left, so does that make it positive or negative? Here's what I like to remember, that rule that we just went over. This is a big number. In order for this to be a big number, this has to be a positive 4. So 6.3 times 10 to the positive 4. Obviously, you don't normally write that positive there. I'm just emphasizing it. Now, right away, this number here is less than 1. So I know that my exponent is going to be negative. I'll just write a little negative up there. So I'm going to have times 10 to the negative something. Now I look, I need my number to be between 1 and 10. So I find the first non-zero number and I put the decimal after it. This is where I want the decimal to be. It's currently here. So I go 1, 2, 3, 4. It takes 4 jumps, so it's going to be a negative 4 because it's a small number. Now remember, we put the decimal here, so 3.72. 3.72. Okay, moving on. Again, this is a big number, so we know the exponent when we finish this one is going to be positive. Decimal's currently here. I need to make it go right there. Now it takes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 jumps. So I know that it's going to be times 10 to the 10. The 10 comes from the number of jumps. Now what I've got here is 3.4. Technically I have to keep all of these. Scientific notation only cuts off the zeros, so to maintain the precision that I have here, I actually do have to write out all this. So it doesn't save necessarily a ton of time writing this one in scientific notation, but just remember that you have to write all the digits that aren't zero. You can only cut zeros off when you write scientific notation. So this would be the answer for number 3. Excuse me. Now, this is already in scientific notation. I have to convert it to a standard number. Now, this is a negative exponent, so I know it's going to be small. I know I'm going to have a decimal, 0 point something. It's going to be less than 1. Now, again, if you follow the rule, move it to the left or right, I don't remember which way the negatives make you go. So what I do instead is just try it here. If I go this way, 1, 2, 3, and fill in a 0, that gives me 3, 4, 5, 0. That's a big number. I know that I need something less than 1 because I have a negative exponent here. So let's make sure we go the other way. 1, 2, 3, 4. Put my decimal there. I fill the zeros in. Now I know 0.0000345 is a small number less than 1. This one is not, so I know that I moved it wrong if I went this way. So just kind of keep that in mind. Negative means small, then you don't have to remember about left or right. So let's do the last one quick here. This is a positive, so it's going to be a big number. So I go 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5 zeros need to be filled in. So 2, 3, 4, 1, 2, 3, 4, 5 zeros. You can put the commas in there if you'd like. And that's how you do scientific notation. So you'll have some practice. Come back to this video if you get stuck. And always let me know if you have questions.